These are your 4.2 notes on properties of exponents and the power function. Most of the notes will be devoted to the properties of exponents, so we're going to start out by talking about what they are, see if you guys can remember how they work, because you have seen them, I think, a little bit in the past. Then apply them to simplifying, so that's a big part of what we'll do. We'll also come across exponents that are fractions, which are called rational exponents, and how you deal with that. That adds another kind of layer to our thinking of exponents. And some solving. So why don't we get into the rules of exponents and get it going here. So when you think about the rules of exponents, it's actually useful to think about expanded form, which really means what does an exponent mean? So if you take a number and you raise it to an exponent, for example, 4 to the 5th, that means that number times itself 5 times. The expanded versions can help you understand the rule. So what we're going to do is we're going to take an expression, we're going to expand it, then say based on the expansion, what's the rule? And then move our way through all the kind of the basic rules of exponents, doing that same approach. So to start, we're going to look at what happens when you multiply a same base. Remember, 4 is our b is our base, with 2 different exponents. And what I'm going to do is expand. So in blue, there's my 6, and there's my 3. And then what do I have total? Well, if I look at the total number of 4s that I have, it's 4 to the 9th. So this would be the equivalent expression, the black, to my original. If you think about what you did, it's pretty easy to see what's going on here. Clearly, you took the 6 and the 3 and you add them together to get 9. So the basic rule then says if you have multiplied the same base together, you're going to add their exponents. And having these rules down helps save you some time, because what we don't want you guys to do is we do not want you to do the expansion. That's actually a waste of time when you're trying to be efficient, working on a quiz or a test, or just doing your homework or whatever. It's good today to talk about this. It helps you understand the rules, but we want you to be able to go from here right to here based on the rule. We're going to keep doing the expansions though, so you guys can see how it works. So let's say we're dividing the same base, and the base does not have to be a number. So here you notice the base is a variable, and that's totally fine. 7x's and 2x's. The idea here is basically a top to bottom canceling. So those two that are top to bottom at least the same, I can cancel those out and then just say to myself, what is left? Well, clearly I've got x to the 5th. So the rule here then is when you're dividing the same base, whatever it is, what do you do with their exponents? You actually subtract them. So again, a basic rule of exponents is divide the same base, subtract your exponents. These two, and there's a couple others we'll hit here in a minute, but these two are probably ones that we'll use the most often. So get to know them really well. So you don't have to do expansion. You can just go from my original problem right to my answer. Okay, let's try some of the other rules. So an equivalent expression where you have an exponent on top that's bigger than the bottom. Now we're still going to do an exponent on top that's smaller than the one on the bottom. We're still going to do the expansion. So there's my 3, there's my 6, and we're still going to do a canceling kind of approach to it. So cross off what I can top to bottom. And then what's left? Now, one of the common errors that students will do is they think about the expansion. They go, well, that's all gone, so I must have a 0 up here. And no, you don't have a 0. When you divide something by itself, you get a 1. And then what's left? 4 to the 3rd. So 1 over 4 to the 3rd. Now, let's say we are going to ask you guys to write it a certain way, like not as a fraction. Then we need to be able to get rid of the 1 over. And the way you eliminate a 1 over idea is you make your exponent negative and you eliminate the fraction. So another rule that we have, and this one's maybe not as clear cut as how it finishes, but it's one you guys definitely want to know, is how do I eliminate a 1 over idea, is you make your exponent negative, and that eliminates your fraction. You can also run this the other way. So we could say if I had 4 to the negative 3rd and I want to get rid of my negative exponent, I could rewrite it as 1 over. So you can run this in both directions. But good to know that it's okay to do from here to do this. Okay, the fourth rule we're going to hit is what happens when you take an exponent and raise it to another exponent. So 4 to the 4th, 3 times. So 4 to the 4th, 1, 2, 3 times. Well, if I get my total number of 4s there, clearly I've got 4 to the 12th. Now, going back from here where I started to my rule, what happened? Well, it looks like to me I multiplied the 2 exponents together, which is what I actually did. So the rule now is when you take an exponent and you raise it to another exponent, you can multiply those exponents together. So those are kind of our 4 basic rules. There's probably a 5th, which you guys should already know. That's anything to the 0 power is 1. We usually don't put that in with our rules. It's kind of something we expect you guys to know, but know that fact, right? Anything to 0 power is 1. Okay, let's see the rules in action with some problems. So I've got a starter set up here that's a little less work compared to say this set down here. We're going to try to do this with show you all the rules and the work as we go. Here we're going to cut out some of that stuff down here and see if we can just kind of do it in our heads. But first of all, identify what it is you're doing, right? So multiplying like base, the rule says to add my exponents, and I would get. When you guys do this problem in homework, quiz, whatever, you don't need to go, this does not need to be there. That's just me showing you the rule. You would clearly just go from here to here in about 2 seconds, hopefully. So now again, identify the rule, an exponent raised to another exponent. So the rule then is multiplication, and my answer is 24. Again, going from this right to this, you don't need this, but today we're doing it just so you can see. Dividing like bases, so division of like bases would be subtraction. So I subtract my exponents and get 7. As a side thought here, it is possible to have these reverse. For example, what if it's like this, and then how do you want to write your final answer? Kind of depends a little bit on the direction. So this says in the format a to the n, so in other words, not as a fraction. I'm going to show you guys what happens if we continue on. So one of the things we'll have you guys do, typically it's kind of a general rule, is subtract wherever the larger of the two exponents is. So here I subtracted 19 minus 12, which brought this b up. If I was going the other way and I said, let's go 19 minus 12, I'd have to bring this one down. The thing that does, though, is it creates the 1 over scenario. And this would be okay if we said, just simplify with no specific instructions. But if we're saying do it as this, then I would be going, bring that up. So you could go this route, or as an alternative to not doing any of this stuff in the middle, I could subtract to the top, bring this b to the 19th up, and I'd have 12 minus 19, which would be negative 7. So it depends a little bit on the instruction, but this is definitely another, think about the difference in these two problems and what's going on with your exponents. Okay, one more with division. So one thing to notice right here, right, f of 0, whatever to the 0 power is an automatic 1. And then that g to the negative 4, if we're saying, hey, let's not have it as a fraction, then we're going to use that rule that allows you to bring it up. So you can make it positive by moving it up in the top of the fraction. Okay, there's the 4 basic rules kind of repeated with some problems in action. Let's do a little bit more with this. And what I'm going to do now is cut out these in-between kind of steps and just have you guys try to just work through it. So again, identify the rule. Multiply the same base. Now with these numbers out front, they're not bases, those are just multipliers. So literally just multiply them together. The rule here is multiply the same base, add your exponents. So we're going to get 8x to the 17th. And this is what we would expect you guys to do. Just go like right to a solution, unless there's a little more work to do along the way, which there may be, like down here, we'll talk about that. Here again, just go ahead and multiply your numbers and then multiply like base, add exponents, so apply your rules. So the numbers just get multiplied together. So 18. And then multiply like base, add your exponents. This is division. So when you're doing the number part of the problem, just do it as you always would, right? Don't do anything crazy about 48 divided by 16, 3. That's it. Those are not bases raised to exponents, are just normal number operations. And then we got division going on here, so we definitely want to subtract those two. So 3x to the third. Now this one's a little bit different because we have this power to power idea, and one of the common errors that students will make is they'll only distribute the power to just some parts of the problem and not the entire part of the problem. You really have to apply that 3 to every single thing that's in here. So you don't need to do this on paper so much, but here's what's going on. That 3 has to be basically distributed to every piece of the problem. So I'm doing power to power, right? So 4 times 3 is 12. This would be an exponent of 1 sitting right here. So 3 times 1 is 1. And then 4 to the third, 2 to the third. Then here, these we can actually, get them worked out a little bit further with number answers. So that's 64 over 8. And then you know what? 64 can be divided by 8. And now we can also apply the rule of dividing like bases, subtract the exponent. So it's kind of a lot more going on in this problem. I don't think it's more difficult, but just keeping track of everything in your final answer. So this is more of what we might expect you guys to do as an end kind of problem. Like, hey, I can do the easy upfront stuff, but can you do a little bit more? Like multiple rules that rolled into one problem. Again, not more complicated, I don't think, just more to sort of keep track of. All right, let's try some other stuff. So some things about negative numbers and negative exponents, just some other confusions that students have, especially like these first two examples, the classic kind of error in how we are thinking about it. And I think this happens because you guys are used to using your calculator and you type certain things in and don't realize really the difference. But a negative 2 to the fourth and negative 2 in parentheses to the fourth. The difference here is the negative is actually detached. So the 2 to the fourth would be done first, the negative applied to your answer, which would look like this. So 2 to the fourth and then make it negative. This one actually says, because in parentheses, that's 4 negative 2's multiplied together. So negative times negative times negative times negative. Well, 4 negative 2's or 4 negatives produces a positive. What happens to students quite a bit is they don't see these as being different problems. Most students will just answer, oh, it's 16, both cases. But it's not, and you have to pay attention to parenthesis, no parenthesis. Some other things are just negative exponents and also negative numbers when they get combined. This is a common error. We'll talk about this one in a second. But here we can undo this by the negative power by doing a 1 over concept. So if we're trying to evaluate like what's the actual number answer now, fine. Go ahead and get rid of your negative exponent, get an answer. One of the errors that I'll see here is that students you're thinking of the rule of make this exponent positive, so I'll go 1 over, and then you think all of a sudden that changed the sign on the number. It does not. So negative exponents do not change signs on numbers. That's another common mistake. When you go to do it, it's 1 over, you got rid of the negative exponent, but this does not become positive because you moved it down. This becomes positive because you moved it down. And then now it's in parentheses again, right? So remember, just like doing this one in a positive 100. So this area here is just kind of some common errors that students make when you're working with exponents you want to watch out for. Another one is a fraction raised to an exponent. So that really is simple enough. You just have to apply the exponent to both parts, distribute it in, and then go ahead and do that work. One thing you guys should try to practice a little bit is, can you do powers bigger than 2 without a calculator? Not that you're not going to be able to use a calculator, but it's kind of nice to be able to do like 2 to the third and not have to think much about it and know that's 8, or 5 to the third, 125. Of course, you can use a calculator if you have to. But the calculator will probably give you a decimal answer also. Okay, last one, so negative. So what we can do here is we can apply the exponent, and then move 2 down, move 5 up, which gets rid of my negative exponents, and then finally do the actual exponent work. This is one way to go. It's a little bit longer. I kind of like the other alternative here, which is you can, look at what's going to happen here. This is 5 halves to the third. So if your exponent is negative, just go ahead and switch. Flip the fraction, make your exponent positive, and then basically you are right here already. And really, probably you're going to go from here to answer. So you can run through this process, but it's probably quicker if you just remember, it's going to get flipped anyway, so why don't I just flip it right away and then apply the exponent. Okay, this is just a whole bunch of kind of the, what to watch for, do's and don'ts, kind of little shortcuts, things to just keep track of as you're working with different rules of exponents. One more thing to hit with you guys is the idea of a power function compared to an exponential function. Power function simply means you've got you've got a x as your base raised to a number, as opposed to a exponential where typically it'd be a base raised to an x. The difference basically is exponential have x in the exponent. Keep it simple, right? Okay, let's do a little comparison of these types. So if you're going through and you're trying to figure out, which one is which along the way, exponent is x, exponent is x, exponent is x, and so on. So exponential would really fit all 6 of these. Power functions, the difference there is your exponent is a number, not an x. So you see like a 6, a 1/2, a 3. This grouping here is all power functions. The solving aspect of this is solve for x. Now when you're going to solve for x as an exponent, this sometimes can be a reasoning sort of approach. Other times you may have to do a little bit of solving, but for starters, what I would do to begin is divide by 6, get my exponential part alone. You could, in some of these problems, you might just ask yourself a simple question like, hey, 4 to what power is 1? Well, that'd have to be 0 because we know anything to 0 power is 1. It's really not like you're doing algebra. It's more of, again, a reasoning kind of approach to it. Same thing here. You might just go ask yourself a question. Well, 4 to what power is 16? And clearly that's got to be 2. When you get problems like this, it's sometimes useful to sort of manipulate this side a little bit. So I'm going to do that. I'm going to say, hey, that's 1 over 4 squared. I'm going to get rid of my fraction, bring it up. And if you can get these two to be the same, I think this red part makes it so much easier to understand what's going on. It's like, well, what does x have to be just to make this a true statement? It's got to be -2. So a little bit of manipulating this side can make this side, I think, just much easier to answer. Okay, let's run through a few more. So here, what I'm going to do again is always kind of manipulate my fraction and do a 1 over idea. When I do that, I got to bring my exponent up. Now, this is an exponent of 1 sitting right here. So I'm going to bring that up, and then I'm going to do combining power to power, right? So I can multiply my 2 exponents together. And if you can just get to the red spot, then answer the question is pretty easy. So -x is equal to 1, so x must have had to have been -1. So what I'm going to do here is apply, again, bring that up, make that a -1. Power to power, multiply. Also, you notice here that I changed this to 3. If you can get these two to be the same, I think it just, again, makes the problem so much easier. So when I see like 3 here and 27, now it has to occur to you that that's 3 to the third, but that's something you guys want to practice and work on, and then I can solve my problem. Okay, one more exponential, but I'm going to switch to a different video here because I'm going to run out of time. We'll do the power function and a couple other things with graphing. So apply your exponent top and bottom, and then again, I think here you just kind of ask yourself a question like, all right, what's it got to be? Well, 2 to what power is 8, 5 to what power is 125, and your answer is going to be 3. Okay, next video is where we'll pick up with power functions and wrap up this section of notes.